one with a mass of 0.25 kilograms and the other with a mass of 0.33 kilograms collide with one another in an elastic collision. If the 0.25 kilogram initially had a velocity of 1.3 meters per second towards the other marble, and the 0.331 had a velocity of 1.5 towards the first, what are their velocities after the collision? Okay, there's a lot going on here, so let's do our exact same setup as we did for the last one. First things first, draw a diagram. So we have two solid marbles. One has a mass of 0.25. One has a mass of 0.33, which I did not leave enough room to write in. One has a velocity of 1.3. The other one has a velocity of 1.5 in the opposite direction, so negative 1.5. And then it says, what are their velocities after the collision? So after they collide, we can assume they're going to bounce off each other. But we don't know how fast either of them are.
So since they are elastic, you're going to have two final velocities.
Mm-hmm. Yep. Hence why we have two equations. Okay. So, first step is set up conservation momentum. Again, just like we did before, but it's one dimension, not two. You're welcome. Okay? So, we set it up just like before. P1 initial plus P2 initial equals P1 final plus P2 final, and P equals mv. So, 0.25 times 1.3 plus 0.33 times negative 1.5 equals 0.25 v final of 1, we don't know what it is, plus 0.33 v1 or v2 final, we don't know what it is. So let's figure out what we can figure out. 0.25 times 1.3, 0.325 plus 0.33 times negative 1.5, negative 0.495 equals 0.25 v1 final plus 0.33 v2 final. That is as far as I can get. I suppose I could add these two together, but for right now, this is a good point to be at. Okay. Any questions up to here? Okay. Here's what we do now. Now, we need another equation. And we have it. Conservation of kinetic... Oh, God, that looks nasty. Okay, let's use this one. So this is conservation of kinetic energy. It's just simplified. And I did some math wizardry, and I simplified it down, and this is what I got. So I'm going to set up a second equation, V1 initial plus V1 final equals V2 initial plus V2 final. Okay? So, V1 initial, 1.3. V1 final, we don't know. V2 initial, negative 1.5. Yes, make sure it's negative. V2 final, we don't know. So, solve for one of them. Now, you're saying to yourself, well, Mr. B, which one do I solve for? The answer is, I don't care. I don't care. But here's what I do. I figure out which one will not give me negative numbers. Oh, if I add 1.5 to the other side, then I won't have any negative numbers. So 2.8 plus V1 final equals V2 final. Questions so far? Set up conservation momentum because elastic collisions conserve momentum. Set up kinetic energy because elastic collisions conserve kinetic energy. Now what I need to do is I need to plug this in. Let's make it different enough. I need to plug this in to my first equation. So V2 final equals this stuff. So I'm going to go back to my first equation, and I'm going to go to V2 final, but instead of V2 final, I'm going to write the stuff. So 0.325 minus 0.495 negative 0.17. 0.025 V1 final plus 0.33. But now I'm multiplying it by not V2 final, but by 2.8 plus V1 final. This is a substitution, if you remember that from math class. Now I've got to distribute everybody's favorite thing. Negative 0.17 equals 0.25 V1 final plus, so 0.33 times 2.8 0.924. 0.33 times V1 final is 0.33 V1 final. Now, let's keep the V1s together. Let's get the number over to the other side. So subtract 0.924 negative 1.094 equals 0.25 plus 0.33 V1 final is 0.58 V1 final. Divide both sides by 0.58. And we get V1 final equals negative 1.89. And we say to ourselves, self, does that number make sense? Well, we have to conserve energy, momentum, and we have to conserve the motion. It was going forward. It would bounce off backwards. Is that what we got? Yes. It was going slower. It hit a faster object, so now it should be going faster. Is it going faster? Yes. Now, we're not done yet. It's easy to finish. Okay? Easy to finish. We found V1 final. We need to know V2 final. Oh, look. V1 final plus 2.8 is what V2 final is. So 2.8 plus a negative 1.89 equals V2 final. V1 or V2 final equals 0.91. And does that number make sense? Well, it was going negative. It should be positive now. It is. It was going faster. It should now be going slower, and it is. Okay? These problems are very logical. Okay? That's not